Curvilinear coordinate systems 1. A vector expressed in a Cartesian system has the following form. Vector v is ex hat plus ey hat plus ez hat. Part A, if this vector exists at the Cartesian point 1, 2, 1, what are its components expressed in a cylindrical system? Okay, first of all, how do we write the position vector in the Cartesian coordinate system? It is x, ex hat. So x ex hat plus y ey hat plus z ez hat. So that's how we express the position vector in the Cartesian coordinate system. Now, how do we transform between cylindrical coordinates and Cartesian coordinates? X is rho cosine phi, the azimuthal angle, and y is rho sine phi, and z is the same in Cartesian and cylindrical coordinate systems. So our position vector is rho cosine phi I hat. We have rho cosine phi ex hat plus rho sine phi ey hat, and we have z in ez hat direction, or we can use I hat, j hat, and k hat for these as well. Now I want to calculate the scale factors for the cylindrical coordinate system. So I have to take a derivative of the position vector with respect to rho. This gives me cosine phi in ex hat direction plus sine phi in ey hat direction. There is no rho for the z part. Now I can take its magnitude to find the scale factor for rho. It is square root of cosine square of phi plus sine square of phi cosine square plus sine square is equal to 1. So this magnitude is equal to 1. Therefore, I have found the scale factor to be 1 for rho. As for phi, I have to take a derivative with respect to phi. I will get minus rho sine phi ex hat minus rho sine phi ex hat. For the other term, I will get rho cosine phi ey hat plus rho cosine phi ey hat. And the magnitude here will give me h phi, the scale factor for phi. That is rho times the square root of sine square plus cosine square. So it's sine square phi plus cosine square phi square root, which is again 1. So this scale factor turns out to be equal to rho. And for the z part, if I take a derivative with respect to z, I will just get ez hat, which means the scale factor hz is equal to 1. Okay, so what is the unit vector in the rho on the rho axis? It is del r del rho divided by the magnitude, which is the scale factor h rho. Now what was del r del rho? Cosine phi ex hat plus sine phi ey hat. Since the scale factor is 1, it's identical to this. So it is going to be cosine phi ex hat plus sine phi ey hat. And now for e rho hat, I have to take a derivative of the position vector with respect to phi and divide it by the scale factor h phi, and that will give me minus sine phi ex hat plus sine phi ey hat, because it's divided by rho, the magnitude. So this is minus sine phi ex hat plus cosine phi ey hat, and ez hat is equal to ez hat, so there is no calculation that needs to be done for that unit vector. Now you can see that going between Cartesian points to cylindrical points, if I take the ratio y over x, I get tangent of phi. So phi is equal to one of the transformation equations. Phi is equal to tangent inverse of y over x. And in part A, we are at the point 1, 2, 1, 1, 2, 1 Cartesian point. So y is equal to 2, x is equal to 1. So phi angle is 63.4 degrees. So we find that phi, the corresponding phi value is 63.4 degrees. And since tangent phi is sine phi over cosine phi, sine phi over cosine phi will give me 2 over 1, which is telling me that sine phi is 2 cosine phi at this point. All right. And you can see that we have the tangent phi is equal to 2, so 2, 1. So in this right triangle, the hypotenuse is square root of 5. So this is our right triangle that is basically describing to us this situation. All right. Now, the vector v has a component on the rho axis which can be calculated by taking the dot product of the vector v with e rho hat direction. Let's take a look at our e rho hat direction. Cosine phi ex hat plus sine phi ey hat. Our vector v is ex hat plus ey hat plus ez hat, so the dot product will give us cosine phi plus sine phi. So the component on the rho axis is cosine phi plus sine phi. But at this point, we know that sine phi is equal to 2 cosine phi. So this is equal to 3 cosine phi. All right. And now I can read what that is. V rho is equal to 3 times 1 over square root 5. Now the phi component, v phi, is the dot product of vector v with e phi hat direction And e phi hat, remember, we have found to be minus sine phi ex hat plus cosine phi ey hat. So the dot product will give us minus sine phi ex hat dot ex hat plus cosine phi ey hat dot ey hat. And we know that sine phi is 2 cosine phi. Therefore, this sum will give me a minus cosine phi. And what is cosine phi? 1 over square root 5. So this is minus 1 over square root of 5. And as for the z component, we have vector v dot product with ez hat, and that is equal to you can see here the vector v has a component 1 in ez hat direction. That is equal to 1. Okay, so we can express our answer. The row component is 3 over square root 5. 3 over square root 5 in e row hat direction minus 1 over square root 5 then we have minus 1 over square root of 5 in e phi hat direction, and then we have plus ez hat direction. So this tells us what this vector v is in the cylindrical coordinate system evaluated at the point 1, 2, 1. So in the Cartesian coordinate system, our vector is ex hat plus ey hat plus ez hat, and this vector exists at the Cartesian point 1, 2, 1. So its components in the cylindrical coordinate system will be 3 over square root 5 minus 1 over square root 5 and 1. Okay, so to answer this first part, I have written the position vector in Cartesian coordinates, used the transformation equations to rewrite the position vector x, y, and z as rho in terms of rho, phi, and z. And then I have taken derivatives with respect to rho, phi, and z. And magnitude of the derivatives give me the scale factors. H rho is 1, h phi is rho, hc is 1. Then the unit vectors are the derivatives divided by the scale factors, which gives me cosine phi ex hat plus sine phi ey hat, minus sine phi ex hat plus cosine phi ey hat, because it's divided by rho, and ez hat is ez hat. All I have to do is to find the corresponding phi value in the curvilinear system, cylindrical system, when y is equal to 2 and x is equal to 1. So that gives me this triangle, and I can see that the angle should be 63.4 degrees, so that sine phi over cosine phi is equal to 2. Sine phi is 2 cosine phi, so that corresponds to this right triangle. I take the dot product of the vector v with e rho hat, gives me cosine phi plus sine phi. The dot product with e phi hat minus sine phi plus cosine phi. The dot product with ez hat is 1. So I can read what cosine phi is here. It's 1 over square root 5. So 3 over square root 5 and minus 1 over square root 5 for v rho and v phi. And finally, I have the vector v written in the cylindrical coordinate system at the point 1, 2, 1.